Hello, and welcome to today's session. In this session, we will focus on learning outcome 3. Understand a simple entity relationship model. Our goal is to explore what an entity relationship model is and why it is a crucial tool in database design. We will break down the core components of models, including entities, attributes, and relationships, and examine how these elements work together to create a structured and systematic database. By the end of this session, you will have a clear understanding of how models help organize data efficiently and form the foundation for effective database systems. Entities are distinct objects or concepts identified in a database. They represent real-world objects like people, products, or events. In a school database, entities could include student, course, and instructor. Each entity has attributes that provide specific information. Understanding entities is crucial for structuring data effectively. Attributes are properties that define an entity's characteristics. For a student entity, attributes could include student ID, name, and email. Attributes hold specific information about an entity. They are essential for detailing the data within a database. Knowing how to define attributes helps in precise data representation. Relationships illustrate how entities interact within a database. They define associations between entities, such as a student enrolling in a course. Common relationships include one-to-one, one-to-many, and many-to-many. These relationships are key to understanding data interactions. Designing effective relationships is vital for database functionality. A primary key uniquely identifies each entity record. For instance, student ID is a primary key for the student entity. Foreign keys link entities, establishing relationships between them. They refer to primary keys in other entities. Like course ID in an enrollment entity, keys are fundamental for maintaining data integrity. Consider a school database with students, courses, and instructors. Entities include student, course, instructor, and enrollment. Each entity has specific attributes, like course name for course. Relationships define how these entities interact, such as student enrolling in course. This example illustrates a basic model structure. Student attributes include student ID and email, with student ID as the primary key. Course attributes feature course ID and credits, with course ID as primary. Instructor attributes have instructor ID and department, with instructor ID as primary. Enrollment attributes include enrollment ID, linking students and courses. Understanding these attributes is crucial for data clarity. Relationships in models have defined cardinalities. A student can have multiple enrollments, showing a one-to-many relationship. Similarly, a course can have multiple enrollments. Instructors have a one-to-many relationship with courses. Cardinality helps in understanding the scope of relationships. In data modeling, type refers to a blueprint defining structure and behavior. Instance is a specific realization of this blueprint. For example, the student class is a type, while an actual student is an instance. Understanding this distinction is key in object-oriented design. It helps in organizing data effectively. A UML class diagram visually represents classes and their relationships. It includes class names, attributes, and methods. Lines connect classes, indicating associations. This diagram is a powerful tool for system design. It helps in visualizing complex data structures clearly. Barker's and IDEF1X notations offer alternatives to UML. Barker's focuses on entity types and relationships. IDEF1X is more database-centric, emphasizing data constraints. Each notation provides a unique perspective on data modeling. Understanding these can enhance your database design skills. Entities, relationships, and attributes are core components of models. Entities represent objects, while attributes define their properties. Relationships show how entities interact. Understanding these helps in structuring data systematically. This knowledge is essential for effective database design. Relationships in ER models define entity interactions. Cardinality specifies the number of instances involved. Operation signatures further clarify interactions. Understanding these concepts is crucial for accurate data representation. They ensure the database reflects the business logic effectively. Operation signatures define entity operations, including parameters and return types. For example, a student entity might have an enroll method. These signatures encapsulate entity behaviors. They are essential for understanding system functionalities. Designing effective signatures enhances system clarity. An ER diagram visually represents business relationships. It shows entity interactions and dependencies. Understanding these relationships is crucial for business analysis. They provide insights into the data flow within an organization. This knowledge aids in designing efficient systems. Relationship directions define entity connections in ER models. Unidirectional relationships simplify data models but limit functionality. Bidirectional relationships enhance flexibility but increase complexity. Understanding directions is crucial for system design. It impacts data retrieval and overall functionality. Relationship directions impact data integrity and system scalability. Unidirectional relationships are easier to maintain. Bidirectional relationships offer greater flexibility. Understanding these impacts is crucial for designing robust systems. It ensures the database meets business requirements effectively. Consider customer order relationships in a CRM system. Unidirectional relationships might only reference orders to customers. Bidirectional relationships allow navigation both ways. Understanding these examples aids in practical system design. It highlights the importance of relationship directions. ER and UML diagrams visually represent relationship directions. Unidirectional relationships show one-way navigation. Bidirectional relationships allow navigation both ways. These diagrams are essential tools for system design. They help in understanding complex data interactions clearly. Conclusion: understanding entity relationship ER models is fundamental to effective database design. Core components, entities, attributes, and relationships define the structure of data, while the direction of relationships influences system functionality and performance. Mastery of these concepts enables the creation of efficient, adaptable, and robust database systems, supporting strong data management practices. If you have any questions, please WhatsApp us at 0748436168. Our team will be delighted to assist you. Thank you for your attention, and see you at the next session.